Hello everyone, so today we have this problem that we want to solve. This is a problem which involves multiple units. Okay, in this case we have two distillation column which is connected in series, and then we have three components that we wanted to solve, which is that we wanted to separate it out through this distillation column, and we want to perform the mass balance for these two columns. And we know that the components are benzene, toluene and xylene, right? And we have some other requirements which are specified in this particular problem. Imagine right now, if let's say you have two distillation column, okay, two distillation column which are in series, and which is in series, and the aim is actually to separate three types of component, three chemical components, which are benzene, toluene as well as xylene. Okay, so we have these three components that we want to separate, and we will inform that the benzene is 30 mole percent, okay, 30 mole percent, and we have toluene of 25%, and we have xylene of 45%, okay, 45 mole percent. And we were told that actually in the first column is actually to separate the heaviest component that we want to leave it out as the bottom product. So here we were told that there are 98%, okay, 98% of xylene in this product. There is no benzene at all. We have only toluene as 2% of the product. And when we were told that as well that the xylene in this bottom product represent the overall 96% of if we compare to the feed itself. So in the bottom product it is actually, okay, 96% of xylene, of total xylene. Okay, so 96% of total xylene is being recovered here. So we can see that at the top product, okay, we have also benzene, which is not going to the bottom product in the first column. We have toluene, okay, and then we have small amount of xylene here. So assuming that, all right, we put a basis mole of assumption that this is 100 mole per hour of this mixture coming in, and then we have N2 as the mole flow rate coming out at the top, as well as N3 as the molar flow rate at the bottom of the first column. So now in your in your benzene itself, we can refer this as, we can denote this as we need to give an algebraic expression for this. Maybe we can give this as XB, okay, toluene is XT, and xylene is actually 1 minus XB plus XT. Okay, so this is the expression that we can put in the second column and in the first column. So now this particular output from the top product of the first column, it enters the second column. So when it enters the second column, we want to recover most of the time benzene at the top, okay, benzene, and then we were told that, all right, there are actually 97% of benzene being recovered at the top in comparison to the feed. But at the same time, we were told that the composition at the top is 94% of benzene, okay, and then the remaining is 6% is actually toluene. There is no more xylene at the top because xylene is a very heavy component, then it goes to the bottom. So at the bottom here, okay, at the bottom part here, we have actually N5. So this is N4. This is N5. another molar flow rate which is consists of benzene left over, which is doesn't not go to the top. We have toluene, all right, and then we have xylene, which is very traces, small amount that is not recovered in the first column. So here you could expect that the only high amount of product recovered in this N5 stream is the toluene itself. Okay, so we can also denote this as let me put, I think because we put here B XB XT, maybe we can denote this as XB2, represent the second stream, XT2, and then this is 1 minus XB2 plus XT2. Okay, so this will represent this stream. So maybe for this one, which is also unknown, we can label it as XB5, XT5, and 1 minus XB5 plus XT5. Okay, so how do we solve this problem? So now, okay, we were told that 96%, okay, 96% of xylene is actually being recovered at the bottom product, okay, from the initial feed, and we were also told that 97% of benzene from the feed is being recovered at the top, which means that some of it which is not being recovered is actually in N5. Okay, so let's think right now about what are the we have already drawn the diagram, we have already given some symbols, we have actually trying to determine what we know and what is unknown. So now let us figure out what are actually the unknowns here. Okay, how many unknowns do we have here? So in column 1, so this is column 1, this is column 2. So in column 1, what is the unknowns that we do not that we didn't know? So first of all, we didn't know what is N2. Okay, we didn't know what is N3. We also didn't know that what is XB2, and we also didn't know that what is XT2. So here we have 4 unknowns. How about column 2? Column 2, okay, again, this is N2, right? We didn't know what is N4. We didn't know what is N5. We didn't know what is XB5, as well as we didn't know what is XT5. So remember, in order for us to solve this particular problem, we must make sure that the independent equation, okay, when the unknowns minus independent equation, it should be equals to 0. So the next thing that we're going to do is to figure out what would be the relevant equations that involve what are the overall expression, independent equation that we can derive from here. So let's move to the next video so we can solve this overall problem.